Okay, guys, welcome back again to our bonding and molecular structure, day 2 of C.3.4. Okay, binary nomenclature. There are 3 forms to learn. The first is binary covalent nomenclature. That's what we're going to be looking at today. The second is binary ionic nomenclature, and the third is binary ionic transition metal nomenclature. It's called stock convention, but for the sake of, you guys aren't going to know what stock convention is. It's always named after a person. So I use bit metal nomenclature in the notes, but you're also going to need to know stock convention, okay? So we have valences are all negative. All nonmetals are negatively charged. You guys remember that from last time when we were looking at the periodic table with the staircase? Okay, so these compounds do not need to be balanced because they're negatively charged. Because of this, prefixes are used instead. This is important. You need to memorize these prefixes ASAP. They are used on every molecular compound, every single type, okay? So we have 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. There's some rules that go with this. The first rule, the first element is given the entire element name. Number 2, the second element is given an "-ide" suffix. Remember suffixes from grammar class? Maybe you learned this in English. So a suffix goes on the end of a word. That's why there's a dash here. The dash represents the root word, and then the "-ide" is what goes on the end. So number 2, second element is given an "-ide" suffix. That means the end. The prefix, which means it goes on the beginning. See this dash here? Mono is never used on the first word. So it can go on the second word, it can go on the third word, it can go on the 5th word. But we're only doing binary, so that means 2 words. So it can go on the second word, but it will never, ever be used on the first word. Okie dokie? All right, naming binary. Bi means 2, okay? Naming binary covalent compounds. 1 nonmetal atom plus 1 nonmetal atom. Remember, that can be a nonmetal or a metalloid. Okay, so here's the compound formula. This is the chemical formula, okay? Remember we looked at chemical formulas and structural formulas. Compound formula is the same thing as saying chemical formula. Okie dokie? So the element furthest to the left or bottom in the periodic table is going to go on the left-hand side. The element furthest to the right or top, so up in this upper corner on your periodic table, whatever's closest to that is going to go on the right-hand side, okay? So this is our compound name. The element name is nitrogen. Now we get a prefix, which denotes the number of atoms. So we have dinitrogen. We have 2 here. So you're really, when you're looking at it, you're saying dinitrogen, okay? Trioxide, so the root plus the "-ide, remember? So dinitrogen, trioxide. It gets the "-ide because it's the last elemental symbol listed, right? So dinitrogen, trioxide. This is for naming binary covalent compounds. Here's some more binary covalent compound examples. Here's our formulas. So remember our chemical formulas, okay? These are our names. So because we can't say mono nitrogen, mono oxide. Remember, that is a no-no. Haha, I did not mean to do that, but it's a no-no, okay? You cannot use mono on the first word, ever, ever. You can use it on the second word. That's why we have nitrogen monoxide, okay? The mono means one. Remember, we're ending in "ide." Notice all of these trending have an IDE on the end, okay? Now, remember when you're reading, you're really counting, you're looking at the number and then the symbol. Looking at the number, if there's a number. If there's no number, you know it's a mono, right? And then the symbol. We don't write with one subscripts because it's not necessary. It's kind of like having shorthand, okay? It's not necessary. You know from this that there is nothing extra, okay? So we're saying di, because there's two, dinitrogen monoxide, okay? So because we don't have two O's, instead of saying monoxide, we're really saying dinitrogen monoxide, okay? Do you see how that works? All right, we have 2 and 2. So that means disulfur dichloride. We're looking at the number first, and then we're calling the chemical symbol as it is. We're looking at the number first, and then we're calling the chemical symbol with an IDE and ending, an IDE suffix. Disulfur dichloride. We're doing the same thing here, okay? We've got dichloride. Uh-oh, here's a big one. You haven't done this one yet. This is a practice. Remember, this is a practice. Hept. Hept means there's a 7 subscript. So dichlorine, because remember, IDE is for the ending ions and for binary covalence, okay? So we're calling it as it is on the periodic table. It's listed as chlorine, so dichlorine hept oxide. Does that make sense? Okay, so more examples. Carbon dioxide. Remember that we can't say mono. We cannot say mono on the first element. Both carbon and oxygen are nonmetals. So the compound must be named as a molecular compound using prefixes and, of course, this suffix. The first element, carbon, gets the whole element name. The second element, oxygen, gets the IDE suffix. Remember, mono is omitted. Omitted means to be left out. Mono is omitted on the first element. Carbon dioxide. Example number 3. Sulfur hexafluoride. Sulfur hexafluoride. Okay? Both sulfur and oxygen are nonmetals. So the compound must be named as a molecular compound using prefixes. 1 sulfur and 6 oxygens give sulfur hexafluoride. Remember, mono is omitted. Omitted means left out on the first element. Sulfur hexafluoride. Okay? Now we're going to pause the video and we're going to answer these together as a class, and then you're going to use your notes and a card, which I will walk around and give to you for a musical chairs game that we're going to play for naming. You are going to have to earn points for your group, and whoever ends up getting the most points wins. Okay? All right. Binary covalent musical chairs.